Hi, good morning, good afternoon, good evening, wherever you're joining from all over the world. Welcome to Managing Projects Without Tears. Today we have a very beautiful topic, a topic that cut across the intersection between artificial intelligence and wireless technology and the application when it comes to the healthcare sector. What a beautiful topic. And thank you. If you're joining us, kindly introduce yourself. Just say hi from America, I from Canada, as usual. And we'll have the opportunity to drop our questions. Kindly drop your comments, kindly drop your contributions. We're happy to see people joining from telecom sectors, the mining sector, healthcare sector, different sectors uh, all over the world. The topic we'll be talking about the advancement. Kindly share your thoughts because most times, during the previous episode, we've seen a lot of cross fertilization of ideas. We've seen concept. We've seen a lot of knowledge sharing, and that is what this platform is all about. We're going to be looking at different latest technologies, looking at the breakthroughs, looking at innovations, innovative solutions, innovations that have happened when it comes to revolutionizing the health sector, the health industry by virtue of using technology. Uh, However, the area you are looking at it from, are you a researcher? Are you simply interested in health care sector? Kindly contribute and kindly ask questions. I will believe that this session will be very, very impactful. All right. A very quick one. We will be having one of my friends, Umar Said, who is a postgraduate researcher of the Coventry University. Okay, so I'll be bringing him on board, as well as my very good friend, Jalili Kazim, is also going to be on board. So kindly share your questions, share your comments as we start. All right, I have my very good friend, Said Humar. You're welcome on board, and our own Kazim Jalili. You're welcome, Sas. So, talking about wireless technology, looking at AI, artificial intelligence, it's a different ball game. We talk about AI, talk about artificial intelligence, and so looking at how the two converge and uh, why this time, especially the focus looking at healthcare sector.
Mhm.
I will allow you to do justice.
Mhm.
Hello, hello, Jalili. Are you on? You're welcome. Welcome. All right, over to Said.
Okay, thank you so much, Tim, for letting me introduce. And I'm just gonna share my screen here. Can you please confirm if you can see my screen?
Yes, I can.
Okay, perfect. Before starting, I will just give a very brief introduction about myself. I'm a postgraduate researcher here at the Coventry University, and we work in the Research Center for Intelligent Healthcare, which is a research center. We basically target mostly healthcare application by the use of wireless technology, wearables, and artificial intelligence. And before that, I've been working in South Korea, where actually I did my master's as well. And now it's been 3 years I'm working here in the Research Center for Intelligent Healthcare. My PhD topic is about wireless technology and artificial intelligence and how we can use it for different healthcare applications. And that's what we are going to be discussing today. And I'm happy to answer questions if somebody's having concerns, somebody's having. As I myself, I'm on a PhD scholarship before as well in Korea and here as well now. So if there are any students who are joining and would like to question about how to get scholarships, how normally academia works in the United Kingdom, and how research center works and how usually to approach them. I would be happy to answer those questions as well. So the topic we will be covering today, I have title is as wireless technology. So we'll discuss very brief, very general, for a very lay audience, what is wireless technology, so everybody can get that. And at the same time, we will get into artificial intelligence, and then we will focus on the healthcare applications. So a bit of motivation about it if we start. Healthcare industry has been evolving and grooming a lot in the past few years by adopting modern advanced technologies and specifically AI based techniques. Uh, in the future, the modern hospitals, the care centers will be fully equipped with sensors, telematics, and remote communication technology. Here are some of the graphs if we can see. So, in the past few years, especially when COVID-19 sector started, the healthcare sector broke the AI with another funding record. People have been investing a lot of money into this sector, and this is where the potential comes in it. So if we see the graph for here, starting from 2018 up to 2021, uh, the funding has been growing up to almost $3,000 million, and big giants and big industries like Facebook or Elon Musk itself, the Tesla company, and all of these big giants are investing a lot of money into healthcare, which actually doesn't come on front usually. But if you guys do some research about it, then you'll get to know that Microsoft itself and all those big giants are investing a lot of money into the healthcare. And in the future, they want to wind it up as well using AI technology and wireless technology and how we can use it in the healthcare sector. And as you can see on the graph on the right side, it has increased by 108%, which was back in 2020 was only $32 billion, while the same industry is growing up to $66 billion. This is some of the states published by CB Insight actually, which shows the potential of healthcare and how big companies and giants are working into it. So this is some of the motivation and why this work is actually important. A bit of introduction actually how these systems actually work. So in healthcare, wireless technology, we can call it contactless technology, we can call it non-invasive technology. Basically, without to define it, it has to happen without any interaction with the human, without any physical interaction with the human. It can be used for several applications, such as patient activity monitoring systems, vital signs monitoring, for example, breathing monitoring, cardiac activity monitoring. And the potential of work which is currently going a lot is elderly monitoring. For example, in the UK, we have care homes where there are elderly, and the systems are needed which can monitor them 24/7 and basically contact the hospitals or the care centers or their designated GPs, which can inform about their health. So context technology merged with artificial intelligence is highly effective and it's easy to implement compared to the traditional approaches because it's computationally cheap and due to modern low-cost GPUs, and it has a lot of potential as well. So this graph here is giving show the general overview how the healthcare industry would work in the future. For example, we have some elderly, we want to monitor them. We have multiple sensors which are monitoring them, and the information is sent in real time to the hospitals, to the ambulances, to their homes, which is connected through internet, basically the Wi-Fi, Bluetooth, Zigbee. We have internet connections. Multiple sources can be used to convey these data sets. And let's say something happens to these elderly, the information is conveyed directly to the hospital at the same time to the ambulances and the homes. And once they are informed, so all of the actions can be taken at once. So, for example, if something happens to someone elderly, for example, they collapse or something happens, the hospital, the ambulances, the homes, they are all informed at the same time. The benefit of it is a lot of lives can be saved, actions can be taken on time, which would actually potentially save lives. And this is where the healthcare industry comes in, merged with artificial intelligence. Going towards artificial intelligence, I'm sure if there are some technical audience, maybe they are aware of it, but I'll just give a very brief introduction. What is artificial intelligence? And just to define it very simply, it is AI uses machine learning, deep learning, natural language processing, and many other techniques to build artificially intelligent models. They can perform high level computations and solve complex problems. Now, the definition itself might look a bit complex because it has a lot of jargon such as machine learning, deep learning, what is natural language processing. But in the coming slides, we would get into it and I'll try to define it in as simple words as I can. Uh, just to define artificial intelligence very simply, I think this slide would help. So, artificial intelligence itself is a huge bubble which covers a lot of topics, a lot of areas. Under that bubble, we have machine learning, and under that bubble, we have deep learning. So, when we say artificial intelligence, we basically mean a bunch of algorithms which are smart enough and which can basically predict things. Under the artificial intelligence, we have machine learning, and under that, we have deep learning, which is kind of the sub part of it. What's the difference? So, AI itself is a technique which enables machines to mimic human behavior. It's a very simple definition, but again, don't generalize it itself because there is no concrete definition of these things until you go into these fields, work on it, and you come up with your own definitions of it. Machine learning we can define as a subset of artificial intelligence techniques which use statistical methods. By statistical methods mean bunch of algorithms to enable machines to improve with experience. And to improve with experience, we mean basically to improve with better data. The more the data we have, the more accurate data we have, the better it performs. Deep learning it's a subpart of machine learning which make the computational of multi-layer neural network feasible. So in machine learning, we have a lot of algorithms, but when we work specifically on neural networks or neural net based algorithms, that comes into the category of deep learning, which is basically the subpart of machine learning. But machine learning and deep learning itself, it's a bunch of algorithms which work automatically. There are so many techniques we can use. I'm not going to dig deep into it because there's a lot to cover. But for example, we have dimensionality reduction techniques, which we comes with the principal component analysis in those algorithms, or we have classification techniques such as we can use support vector machine, or if we talk about deep learning, then we can use artificial neural networks. We have unsupervised learning, we have semi-supervised learning, we have reinforcement learning, and so many techniques which comes under the umbrella of machine learning. And all these tasks, according to what the application and the work we are doing, we can actually use all of these aspects of machine learning. Just to define very simply, what is machine and deep learning? So, Arthur Samuel defined it as field of study that gives computers the ability to learn without being explicitly programmed. So, this line here is very important actually when it says without being explicitly programmed. So, when we think about machine learning, deep learning, we think, oh, it's going to be a lot of programming, coding, and we have to learn a lot about it. But it's actually not true. Studying machine learning and deep learning itself is quite simple actually. You need a bit of background in mathematics and statistics where you can learn how actually algorithm works, but it doesn't need a very highly qualified programmers or coders who can actually write it, because in the modern era we have platforms such as scikit-learn, we have tensorflow, we have keras. These are all libraries, and when I say library, take it as a simple library. It's a bunch of books, which means a bunch of algorithm content. The way you go to a library, you take a book, you use it, it's exactly the same way. That's why it's called library. It has bunch of algorithms. You just take the algorithm which you want to use, you do tweaking and the parameters according to your application, and that's it. You are done. You just give data into it as described here in the figure. We have a bunch of data, we give it to the algorithm which we have already through different libraries and platforms. Especially using Python, it's been very easier now. And you just do a bit of tweaking and the parameters, you train your machine learning model, your model is ready, and then it do the work for you, predicting outcome. The second definition, which is by Albert Alexander Simon, who also won the Turing Award in 1975 and also a Nobel Prize in economics. He said learning is any process by which a system improves performance from experience. Very simple definition. I love this one. It basically says learning is any process by which a system improves. By mean a computer or machine improves from experience. And whenever we say experience, we mean data actually, a bunch of data we have, and that data makes the experience better and the performance much better. But again, data itself, a lot of data is important, but a lot of accurate data is important. I would say the data itself has to be very accurate, and that's how the algorithms work better actually. Bunch of simple more definitions. I would just dig deep into it. Bill Gates defined it as a breakthrough in machine learning would be worth 10 Microsofts. This definition here defines how important machine learning and deep learning and basically what AI is. Machine learning is the next internet. That's how Tony Tether, former director of DARPA, introduced it. The Stanford president said machine learning is the hot new thing. Parag Raghavan said his web rankings today are mostly a matter of machine learning. Another definition from CTO, we have machine learning is going to be result in a real revolution. It's already is, but so many people don't realize this, that machine learning itself was introduced in the early 2000s. So it's not a long time ago. It's been 2 decades now, 20-25 years maximum. And there is still a lot of improvement. The work is going. And why now is the time to actually people dig deep into it, learn about it, and apply these things in their businesses if they are doing their jobs, if they are doing, and lots of other sector they can work on it. AI versus humans, why these things are important. So, for example, this example here shows the Deep Blue won its first chess game against world champion Gary Kasparov and game one of the 6 game match in February 1996. This was the initial starting of how AI algorithms can actually perform better than humans. Then later on in 2011, the Watson computer system competed on the quiz show and against champions Brad Rutter and Ken Jennings and won the first prize of $1 million. So these were the initial kind of stages of how the computers actually broke the humans in itself, and they've won from then. And this was a bit of changing time for the world when they realized actually machines can perform better. Another few examples. So during the Turing test was passed for the very first time a computer program which was named as Eugen Ghostman during the test in 2004, and it was held at Royal Society in London. This is a very nice present. There is a whole documentary on this one on YouTube. If anybody is interested, they can watch it. It's amazing. I would recommend everybody to watch it. There was a Go match between a teen-time world champion, Korean winner. His name is Lee Sedol, and it was with AlphaGo. Sorry. Sorry, I'm having a bit flu. So this AI-based program developed by Google DeepMind that was recently in 2016, and the AlphaGo actually won the game and the prize money of $1 million. So it's quite interesting actually how a teen-time world champion actually lost to a machine. This actually shows how these algorithms are quite effective and it can work in different sectors. These are some of the examples I showed which actually proved how the machines can work better than humans. It's a good sign and it's a bad sign as well, because eventually these algorithms and bunch of sectors might replace so many workers in their jobs, which is already happening with softwares like ChatGPT and other techniques. Why artificial intelligence and why now? Why at this time of the era? Because it has the ability to mimic human and replace certain monotonous tasks which require some intelligence, like recognizing handwritten characters. Seems quite a simple task, but we have a bunch of data. We can fed it into machine learning and we can have it our own. Second is develop systems that are too difficult, expensive to construct manually because they require specific detailed skills or knowledge tuned to a specific task and knowledge engineering bottleneck. We have flood of available data, especially with the internet. We have increasing computational power. With less money we can have a lot of GPUs, which was quite expensive in the past, but now it can be very cheap as well. We have growing progress in available algorithms. Every day, every year, some new algorithms and techniques are being published by the researchers throughout the world, and which is actually making this process way easier, and it's going to be way easier in the future as well. And it has increasing support from industries as well. So this could be the right time to actually invest the time and knowledge into these things and learn about it, and to actually start a career at it as a data analyst, data scientist, machine learning engineer, data engineer, or potentially going to academia as well and working on this as a researcher. Coming towards important part, how this sector works in the healthcare and multiple applications of it in healthcare. So if you look around, go to Google Scholar, you can find hundreds of papers which have been working on it, and the applications are enormous. For example, we have rare disease diagnostics and treatment, drug development, medical diagnosis, dosage error reduction, cancer research, personalized healthcare plans, virtual nursing assistance, fraud detection, cybersecurity, gene editing, AI robot assisted surgery. And these are one of the few applications of AI in healthcare, but there are a lot. Health monitoring and wearables. So basically, I'm going to talk specifically into healthcare, but in every field, if it comes, for example, cybersecurity in healthcare or any businesses, we can implement these tools and techniques which can actually automate the system. Coming towards my work, what specifically we have been working on in my PhD studies. So the healthcare application which I'm focused on and working on is respiratory diseases, or in other words, we can call it breathing diseases, which commonly comes with, for example, cystic fibrosis, emphysema, and pneumonia. Or, for example, if somebody is going to asthma and they're having difficulty breathing. On the right side, this graph actually shows different type of breathing patterns, which we can actually show through a signal. So, for example, every human who are breathing, they are having a specific signal for their breathing. So eupnea is a normal breathing pattern, which means a very fine line with same frequency and the signal is going. Bradypnea is defined as a slow and shallow breathing, and so is tachypnea, which is fast and shallow. Sighing is caused by frequently interpressed sighs, which is caused by anxiety, depression. Biot is caused by spinal meningitis or by head injury. There is another type of breathing called Keenstock, which is caused by brain tumors. And Cosmal is one of the breathing which happened a lot during COVID-19 times when people were affected, basically having fast and deep breaths. And the last one we have is caused through the heart and kidney failure when you get a straight line after some time. So these 8 breathing patterns is one of the few patterns. Of course, we have more. I think currently we have 12, 13 different type of breathing patterns caused by different diseases actually. And the goal is to monitor these breathing patterns until something happens to a patient or somewhere, so we can predict actually what is going to happen to them in the future, and accordingly their hospitals and emergency services can be informed. So objective of my PhD work is to design a system based on contactless technology. We can call it wireless technology or non-invasive technology, and we call it basically radio frequency sensing. And we use two major technologies for it. We use radar and Wi-Fi technology, and then we merge it with machine learning and deep learning approaches to detect and monitor shortness of breath, or we can call it irregular breathing or irregular respiratory. So this here is a very simple nice graph I have put for you guys so you can understand. So here on the left you can see the animation. When the person inhale and exhales, the chest moves, it convex and contracts. So even if you notice yourself, whenever you breathe, your chest has a very specific displacement and motion based on your breathing pattern. If somebody is having a bit healthy body, might they be moving a bit more chest? If somebody is having skinny body, might be a bit less. Anyway, based on these chest moments and chest displacement, we actually identify if the person is having normal breathing or abnormal breathing. So for example, here is a PC where I have connected either radar sensor or a software defined radio sensor. I'm not going to get deep into how this technology works, but I'm just going to talk about overall application of it and how this works. So these sensors, which is having a distance of around 100 to 200 centimeters, it transmits a signal which hits the chest of a participant or any human body. It receives back the signal, then we analyze the signal, and based on that we define, okay, if a person is having normal breathing or abnormal breathing. So for example, here on this graph, I'm going to zoom in a bit. If you can see, when we collected data from our participants, so when they were having a normal breathing, normal respiratory, we were getting a signal which was quite frequent in frequency and amplitude. But as soon as they were having elevated breathing, which means fast breathing, and let's say they're having an attack, asthma attack or shortness of breath, for example, breathing very fastly, like this means the chest is moving very fast and they are actually having an attack. So we suddenly got a very elevated signal, and based on this signal, we collected a lot of data. We put it into the machine learning classifier, which is basically a bunch of algorithms we used, and then it detected for us either if the person is having a normal breathing or abnormal breathing. So how this system actually works, once we train a system based on a bunch of data, and we have it in the form of maybe numericals, maybe spectrograms, maybe microdoppler signatures, any type of data, then we train an algorithm based on that. So let's say if a person is having an attack due to any type of lung diseases or respiratory diseases, so these sensors or these algorithms can detect and say, okay, this person in the next 2 minutes maybe or 1 minute might have an attack like this, or might have an elevated. So as soon as it detects or monitor them, in the meantime, this everything can be transferred to the hospitals or their doctors to inform them about it, and the actions can be taken accordingly. Now the questions which should be coming to your mind is that why wireless technology? We can use camera for this technology. We can use wearable sensors. For example, we have Apple watches and all those things which can actually do these things, and we have other sensors as well which you can put on the chest and monitor them. The selling point is because the world is going towards wireless technology, and it is more convenient than the camera based technology or other wearables. And I will tell you why. For example, when COVID-19 started, we could actually do not do any interaction with the patient, not physical touch at least. And to attach those wearable sensors on them or the technology on them, that required, maybe that can actually potentially transfer the viruses from one patient to another, or potentially to the care, to the nurses or to the doctors as well. And that's why we need wireless technology which can actually eliminate any type of human to human interaction. So while in the wearables it is not possible, and that's why we are moving it is a research which is ongoing. It's not perfect, it's still a work in progress, but the selling and the idea point is to make any type of monitoring of the patients completely contactless and wireless. Now the second question is, why not camera based technology? It is contactless, it is wireless, we can use that too. Yes, there are thermal cameras which can work as well, we have RGB cameras which can work as well, but they're computationally very expensive because they give you data in the form of images or videos, which makes it computationally expensive to process them. While in wireless technology, we can get data in the form of numerics, simple matrices, radio frequency sensing. We have bunch of numeric values which can actually get us a signal, and then we can identify based on that. So we can say RF has potentially some pros according, compared to all these other technologies. Compared to camera based technologies, it is computationally cheap. Compared to wearables, it eliminates human to human interaction. And that's why the research is going a lot towards radio frequency sensing. How does this radar based, for example, system work? So in the past, when, for example, you guys go to the airport or somewhere, you see this huge radar on the tower which is monitoring the aeroplanes and consistently revolving. Those are conventional or traditional radar systems. But in the modern times, as I said, the world is changing every year. We are having new technology. So as you can see here in this picture, on the right side, on the left side, I'm having two radar sensors. And as you can see how compact, how small in size these sensors are, literally this much of a size. And these radar sensors inside have transmitter antennas, receiver antennas, which can actually transmit signal, receive signal, and based on that, it can calculate by the velocity and by the time of it, that how is the data we are getting. So for example, if we want to monitor a patient, we have these sensors, we deploy it somewhere, it is continuously transmitting the signal, receiving the signal, while monitoring. It's could be cardiac activity, which is heart monitoring, could be respiratory monitoring, could be any other moments, for example, head motion, hand motion, finger motions, lip motions, could be any type, basically any type of motions can be detected, either very minute or either very big. But you just have to define a frequency specific for it. For example, the breathing frequency is zero point 0.1 to zero point 0.8 hertz, I think. And based on that defined frequency, you can get a signal on that and then analyze it and get your data. So we generated some bunch of spectrograms. We performed some training data testing, validation data. We had I have been working on residual neural network, which is a well-known deep learning algorithm. And based on that, we had an accuracy of up to 90% in detection if a person is having normal breathing or abnormal breathing. This image here shows the data we have been collected from our participants. Of course, due to several complications, we couldn't get the actual patients who are having respiratory sickness or illness,
Yeah,
but
sorry to cut in.
sure,
Sorry
sure.
to cut in. Yeah, a question came up.
Mhm,
How do you manage interference? Looking at especially the wireless technology aspect of
mhm.
it. Yeah,
Okay.
and so that's one question. Maybe you want to
That's,
attend to
that's
that
that's a
first.
very that's a very good question. Whoever asked this question, I'm sure this I'm sure they're very informative. It's a very good question. Yes, one of the drawbacks of radio frequency sensing is the interference. So, for example, you're having your Wi-Fi, your smartphone, or any type of electronic devices. It can interfere with your signal. So for example, if you can see here in this picture, we are having a sensor. It is collecting data from a participant while hitting directly their chest. But in between, if you are moving your hands or your head or any type of other signal interference, then it is not going to give us a very reliable signal based on the interference. But the solution for that is, as I mentioned in my earlier slide, the frequency definement. So the activity you have been monitoring, you have to define a frequency for it. But frequency, actually, to define it in simple, the large moments are you are having a large frequency, the small moments you're having a small frequency. So if you define that frequency, you can actually extract what information you need from that signal. So for example, if we go back here into this signal picture, uh, I'm having this sensor and I'm, for example, monitoring someone who is walking, continuously walking. Now, walking is a big body movements. So I'm gonna have this frequency quite high actually, and I can define it accordingly. But if I want to monitor someone who's just their breathing and respiratory, then as I defined, the respiratory lies frequency between zero point 0.1 to zero point 0.8 hertz or zero point 0.9, but it's very minute frequency. So by defining those frequency in our signal extraction techniques, we can actually extract the specific information what we need, and then we can use that information. But yes, interference could be there, and it can actually mix up our signals. And to remove those, like one of the limitation, I would say the huge limitation of RF sensing is all these experiments you see, it is performed in a controlled environment, or we can say in a static environment. So the person we are collecting data from, they were not moving their hands a lot, they could not move their body a lot, they were in a static position breathing, and the data was being collected from them. uh, so if you basically move a lot, and there would be an interference in the signal, because it would be collecting a lot of information of your body movements and everything, and it gets very hard to extract specific signal you are looking for. Of course, you can still do that, and the work, this is still the work in progress. Researchers are trying to uh, somehow limit this. One of the biggest limitation of RF sensing, that the experiments are performed in a controlled environment. So for example, if you are having a patient in a hospital or care homes, and they are continuously moving in the room, we might not be able to extract exactly their respiratory. But as long as they are reliably sitting on a bed or in a chair and the sensor is there, then we would be able to extract that information. But if there is a lot of moments going on, then the information would not be accurate with us. So yes, that's a very good question, and I think it is still one of the limitation, and the work is in progress in this field. Yeah, I hope I answered the question. So
Yes,
some of the,
very well. Go,
yeah, some of,
right on before the second question.
okay, sure, yeah.
Okay, yes, you can write on. The second question is coming on now.
Okay, it's coming up now, sure, yeah. So some of the results which we got from our work, and when we use machine learning, and as I said, I've been working mainly on the residual neural network. So here on the left side, this shows the confusion matrix. When we classified the abnormal and normal respiratory, we got it up to 90% accuracy actually. Here is our model loss, model accuracy. I'm not going to get deep into it because it itself is a bit technical. But here on the right side, it shows when the person was breathing normally, how much was the Doppler hertz we get, which is basically the frequency. And the data was recorded for 15 seconds, which let us know how the person is breathing and is it elevated or not elevated. And here on the below figure, it shows the difference between normal respiratory and elevated respiratory, or we can say fast breathing actually. So as you can see from the figures as well, it is possible to see into the naked eye. So the questions it should be rising, if we can see this directly through signal processing, that if a person is having normal breathing or abnormal, why use machine learning? And the answer to that is that all the data is not going to be as accurate and visible as this one, and this is where we need machine learning. So for example, if a person is having normal breathing and abnormal is very minute differences with the normal one, it is not possible to the naked eye to distinguish between them, but a smart algorithm based on deep learning would be able to differentiate between them very easily, and hence giving us true positives rather than false positives, which is quite important actually. So in this case, why we need deep learning, machine learning is quite important. Second type of technology we have been using, so first I mentioned about radar technology, how it can be used. The second experiment which we did is based on software defined radio technology, or which is actually Wi-Fi based technology. Now these are normal Wi-Fi signals, the one we are having in our home. We are having the modems, the transmitters, which is actually working. So it is not visible to the naked eye, but all around us is the radio signals everywhere in the form of Wi-Fi signals. And the idea is to use these Wi-Fi signals. So for example, if my hand is waving like this, for sure there is some signals going on, and with my hand fluctuation, it's going to block the signals. A very simple experiment: if you have router at your home, go block the antennas of it or do something, then actually your hands are going to block the signals or maybe release very few signals, which actually shows you that physical interference can actually interfere with the radio signals. And this example here shows you how you can actually use this signal to your own benefit and detect a bunch of different human body movements through it. So the experiment we did, we had a device called USRP. Here is the USRP device. It's quite expensive device because it's 5G communication device. The model we have been using is called X310, and USRP means Universal Software Radio Peripheral, and it's a device used for 5G communication. So it has a antennas which can be used as transmitter receiver, and here we have the directional antenna. And as you can see here, I'm sitting, so the transmitter antenna is hitting my chest. It is getting back reflected into the receiver side, and on the computer we are trying to analyze the signal if it is able to detect my heart activity and my breathing activity as well. So the difference between radar technology and this technology is this technology is quite powerful. It's called software defined radio. So it's, to define it simply, it's basically a radio which is software defined. So in the old times when we had radio, we have to analog radio, we have to manually uh, scroll the things to make it adjust to the frequency we require. But in these devices, it's based on software defined radio, and it has a very huge bandwidth, I think starting from 300 megahertz up to 6 gigahertz and something, which is quite a large bandwidth, and we can use any of those frequency to work on it according to the different applications we need. So once we collect data from these kind of sources, we get in the form of channel state information. So here, if you can see, for example, the last one, when the person is having a normal breathing, the signal was actually quite same, and coming, it was defining it as a normal breathing. Later on, from these signals, we do some feature extraction technique, which is again artificial intelligence based techniques. We have training data, we have our testing data, then we use a bunch of machine learning, deep learning algorithms to detect and classify those signals for us. So in this case, for example, we performed up to classify 8 type of different respiratory signals. We collected the data from different participants with different human shapes and bodies, healthy and not healthy as well. And here in this graph, as you can see, the A shows normal breathing, B shows different breathing, C shows different breathing. So as the human was changing their breathing, the signal were getting were quite. So as you can see, the graph itself is quite accurate in showing the signals according to the how the human was breathing. And this actually shows the promising idea that how these technologies can be used to detect different type of motion. And my work is specifically on breathing, but it can be used for a lot of things, for human activity, for example, hand motion, legs motion, walking, sitting, standing, head motions, eye motions, lip motions, um, cardiac activity monitoring, which is heart activity monitoring, breathing monitoring, and any sort of, basically any device and anything which is having a motion can be used. So when your cardiac activity, your heart is having a beep and a moment, those activity can also be monitored through radio frequency technology. So using this technology, the results we got was we used 6 different type of breathing, and we got quite good results.
Sorry
We
to
got
pause you again.
Sure, sure,
Uh,
sure.
yeah, two questions. One talking about the safety when it comes to Iman.
Okay.
One is saying how safe is it when it comes to interacting with the human body. The
Mhm.
second question, summarize, is talking about um, passive devices. You've got active devices in a typical telco infrastructure, the cycle, your
Mhm.
home office network that you've talked about, um, wireless adapters and the rest of them
Mhm.
internally, the
Mhm.
router. Then you talk
Mhm.
about the base stations, the passive equipment, the telco, towers and the rest of it that communicate. So does the SRP depend on the radio frequency coming from the telecom industry to
Hmm.
function? If the answer is yes, so what's the risk if there's a breakdown in that telco infrastructure? Is there any other plan? That's just to summarize that question, the two questions. The first
Okay.
one talk about the health
Okay. Okay. So
safety.
I got it. Okay. So the first one was about health and safety, actually. So when I was doing my experiments, I had to go through a rigorous process of getting permission for these experiments because, as you might be aware, in the United Kingdom, there is regulations to use these frequencies. Anyway, to get the permission for my ethics in terms of doing this experiment was these devices. For example, USRP itself is made by National Instruments, which is a huge company based on United States, and they make these instruments. And by IEEE organization, the frequency which these devices have been used is declared as completely unharmful. It does not uh, produce any sorts of irritation or something to the human body, because the questions which can be raised, okay, can these signals produce any type of skin irritation or maybe cells something inside the body or anything? Sorry, and the answer to that is no. According to the IEEE and by the National Instrument and all the health and safety organization, they have declared these devices as completely unharmful to the human body based on the frequencies they work on. uh, I wish I had a graph to show, but all these frequencies have been defined by, so for example, we have radio waves, we have microwaves, we have gamma rays, we have x-rays. So these x-rays, the gamma rays, microwaves, because they worked on a very high frequency and bandwidth, of course those are harmful to the human body. But these RF signals are unharmful because they work in a specific uh, bandwidth, which I defined initially. I think USRP is 300 megahertz up to 5 gigahertz something. So any signal which relies between the specific bandwidth, they are declared as unharmful to the human body, which does not impact the human body in anything. So that's why in terms of health and safety, it has been declared unharmful, and that's why the work in the research is going on throughout the United Kingdom and other parts of the world. The second question was related to, I think, telecommunication and how. I'm not sure if I got the question completely right, but I'll try to answer it from
Okay.
my way.
Yeah.
Yeah.
The risk, the question is talking about the risk in terms of the fact that the device depend on passive equipment uh, of telco,
The
or does it
device itself.
generate? Yes.
I don't not sure what do they mean by depend on the passive, because if I answer it correctly, I don't think it depends, because it itself is a 5G communication device. So yes, it has been used in the telecom industry and maybe a lot of industry for different type of applications, but we try to utilize these devices independently, just only this device along with a bunch of antennas, to use it for healthcare applications. It has been used in other sectors for a long time now. People have been using it specifically in telecom industry and other, because it is a 5G communication device, but we try to use it for specifically healthcare applications. And the reason for that is because how powerful these devices are, how largely the bandwidth they cover, and how flexible these devices are. As I defined, it is a software defined radio device, which means you can actually play around with it, do a bunch of stuff with it, and you can software wise change most of the parameters of it. So if, for example, if I'm working on breathing, I can define the frequency accordingly and use this device. But my colleagues work on large body movements, for example, sitting, standing, walking, to monitor a human, and they use the same device but with another bandwidth and another frequencies. So the device itself can be used in schools, colleges, universities, academia, industries, anywhere. According to the applications, you have to define your own parameters and
So
use it. Yeah.
the is does it mean the device does not depend on bandwidth to function? It transmits uh, wavelengths. It transmits signals itself.
Yeah, I mean it does transmit, but it is dependable on bandwidth for sure, because every radio device has a bandwidth. Every radio device you see has its own bandwidth, but the question is how large and how big the bandwidth is. For example, the radar technology we use has it does not have a very huge bandwidth, so we are very limited in terms of applications to that. With this device, we were able to differentiate between 6 7 different type of breathing patterns. But with the radio device we were using, we were able to do only two type of breathing, because it's very hard to differentiate between that. It does not give us a very reliable data. But this device can give us a very reliable data because of how large the bandwidth is and how much we can play around with it. So we can actually get a signal, play around with it, and actually get way more accurate data than those small
Okay.
compact radar
So
sensors.
is
Yeah.
the device connected to the internet?
No, no, it's just connected to the power, and then this device is connected to the laptop here. So there is no internet involved. I can actually
Okay.
run this whole
So
system without internet.
in
Yeah.
in in other words, so you can create within signal, generate signal just within something like a wireless router,
Yeah, yeah, yeah.
the way
As I said,
home office network could
exactly.
be
Yeah.
to
So as,
generate and it does not depend
yeah,
on telco
no,
infrastructure to send to the internet. All right. Oh,
yeah.
that's beautiful.
So even the system you are seeing here in this picture, which is actually running, is a completely offline system. There is no internet involved.
Okay.
Yeah.
Okay, I think
But
that's
as
the that
yeah,
yeah.
but as I said, there are multiple devices you can use. For example, the device we have here cost up to 10,000 pounds, so it's quite an expensive device actually. But there are research papers you guys can find about who uses the simple home routers we have, the Wi-Fi routers we have at our homes. They utilize those routers to actually detect the human activity, and they have got very accurate results actually. But the limitation of those devices and these devices, the the versatility of the device. So you are limited to use the Wi-Fi routers. It doesn't give you a lot of options because it's a very small and cheap device which gives you a very specific signal and frequency. While this device, it is expensive for sure, but it gives you a lot of flexibility to grow. It gives you a huge bandwidth. It has a bigger daughter boards. The processing power is quite high, so it gives you the flexibility to do all this in real time actually. So but you can use the Wi-Fi. People have been using Wi-Fi routers actually. If you guys go to Google, search on some paper, for example, human activity monitoring using Wi-Fi routers, you would find a bunch of papers. Amazing work have been done. They just use simple home-based Wi-Fi routers to detect human activities, and I think it's an amazing work, which works quite same as this system, but this is more advanced in terms of you can play around more with it. Yeah. So I hope it answered the question. So the results we got from this device was quite amazing as well, quite accurate as well. The limitations in every field and every research, there comes a limitation, and the limitations of our work, which is radio frequency technology, is limited range. So all these devices have specific range, and you have to work according to that range. For example, the radar devices, the experiments we did was the distance was about 100 to 150 centimeters. With the software defined radio device, the distance was a bit far, but still there is a limited range. You have to work in that range. Second limitation is line of sight requirement. So all of these devices you see, the work was done exactly in the position where the activity was performed, which is called as line of sight. So these devices has to be positioned directly towards um, a person or a patient where activity is performing. So it cannot be in the backside. The experiments has been done. For example, I'm currently doing this work that can I monitor a patient from backside, and would it be able to detect their heart activity or their breathing, because they can penetrate through the human body as well. So this is also one of the limitation. Second limitation would be, third limitation, which the questions we get, is interference. Yes, a bunch of interference can happen, and accordingly you have to apply different signal processing algorithms to extract the signal and information what exactly you are looking for. Fourth limitation is the power consumption. Especially the big devices we use, as I showed, the USRP, it consumes a lot of power, so power consumption could be reduced in the future. Fifth would be privacy concerns. Although compared to the camera-based technology and wearable technology, RF technology has the least concerns about privacy, but still there are privacy concerns, and we have people in our research center who work specifically in terms of cybersecurity into RF technology. So, for example, if we implement RF technology in healthcare, how we can um, guarantee basically the privacy of the patients, and so no data can be leaked accordingly. Another limitation is environmental variability, which I mentioned that most of these experiments were performed in a static and controlled environment. So if a lot of actions are happening, a lot of moments are happening, probably we are not going to get the accurate data, and which needs further research work in the future. Another limitation is calibration and maintenance. So some of the devices are very hard to calibrate and maintain, especially the USRP device I mentioned, because these devices are very complex devices. As I mentioned, these are 5G communication devices. So the calibration issues can be there, maintenance issues can be there. But once you get there, you get accurate result, then you can actually maintain that for a long time. Another question we got, which I actually mentioned here, the regulatory restrictions. Is it regulated by the government, by the country? Is it allowed, the signals? And those could be limitations in some of the countries, not necessarily in the United Kingdom or US, but some of the countries might have a restrictions on the specific frequency you are using, so you might not be able to use those signals because of the restrictions on them. Last limitation is cost. Some of these sensors and devices are quite cheap. Actually, you can get 100 to 150 pounds, an amazing sensors which can do a lot. But at the same time, as it is a new work, new technology, so it is quite expensive itself, because it's a work in progress. The research is going on, so the cost currently is quite high. And but in the future, when we have a lot of diversity in this field, probably the cost is going to be reduced. So it is always a good idea to mention the limitations of your work, because it gives a chance to other people in the future to actually work on these limitations and reduce it, to make the product and the world itself a better place actually. Yeah, that's it from my side. Thank you so much, all of you, for listening. If there is any questions, please pop up. Yeah.
Thank you so much.
Mm.
Uh, question, kindly drop more questions as we wrap up.
Mhm.
I don't think we can exhaust the questions
Mhm.
because of the time.
Mhm.
The next question talks about geospatial, uh, spatial technology. How do you look at this technology that's comparison with the wireless technology? So somebody stressed that
Mhm.
during COVID-19,
Mhm.
you've got researchers who saw telecom, that is, there's mobility data, just like you talked about some of your colleagues, uh, the entire world in terms of health could not, data was the problem, right? So
Mhm.
talking about geospatial data,
Mhm.
geospatial information, looking at mobility data. We
Mhm.
cannot get the real data, at least we can be able to get um, related data. And
Mhm.
that shows how people move from one location to the other by virtue of telecom infrastructure.
Yeah.
So from this position, I've moved from here to this place. So invariably, the objective is to confirm how many people left their houses, how many people
Mhm.
have contacted COVID-19, and you'll be
Yeah.
able to have traceability and the rest of it. That
Yeah.
research, is ongoing. Now,
Yeah.
looking at that in consonance with comparison with this technology, how do you what's your talk around
Mm.
that?
Mm. So, so coming back to my project actually, so my PhD starting during COVID time, which was a peak COVID time, and my
Mm,
project started as COVID-19 symptoms detection using contactless technology. And the selling point of that was because the hospitals needed a technology which can eliminate human to human interaction, because the virus itself could be transmitted using the wearable sensors and other technology. And our selling point was, okay, this is the time that we have to focus on the wireless technology, because in the future, all sectors, not just healthcare, all sectors would be moving towards the wireless technology. I mean, look at us now, the phones we are having, the laptops we are having, and we are moving, the world is moving towards wireless. And in the
mm,
next 10, 20, 30 years, the goal is to eliminate any type of wired connection. Even the internet is going wireless.
exactly.
Yeah. So that was the whole idea of it. But of course, the COVID has finished now, so we are shifted our project towards future pandemics, and at the same time, people having lung diseases such as asthma or COPD or any type of other lung diseases actually. And these devices itself has a lot of limitations, as I mentioned as well, but it is a work in progress. It is still a long way to go. Maybe in the next 5 6 years we won't see it as an application in care homes or hospitals because there is limitation in it. Our results are quite good and performing well because we perform it in a controlled environment in a very specific, but the real life situation is different. As you mentioned, if I'm doing it in one side and I move a bit, then it might be different. And to answer that, we need a lot of data and very accurate data actually. And if you go to the internet, you would find a lot of data sets to play around with it, but you would not find much in the healthcare sector. Because first, the research is not there a lot, and if the research is there, a lot of data sets are not publicly available. And if the data sets are publicly available, maybe you don't want to use it for your application is different. For example, I work on respiratory, and it is very hard for me to find data on breathing using the RF technology on the internet. Yes, there are some researchers who have made their data sets publicly available, but not a lot. And at the same time, it's not reliable as well. These have complications, and this is why we are working on our own. We are collecting our own data. We are working on it because we need reliable data from our own sources. So data limitations in this sector is also a huge problem, which I think we need to cover up. So it is a very futuristic work. As I said, in the next 5 6 years, maybe we would not be able to implement it, but eventually this is going to happen. This is the future. This is how we would end up with wireless technology. As soon as we remove these limitation in terms of interference, in terms of cost, in terms of reliability, in terms of regulations, the more we reduce these limitations, the more we would be able to come up with very accurate platforms, and then we could actually use these RF technology for a lot of sectors. Yeah.
All right. Maybe we'll wrap up with this because there's a lot of questions. I hope we're going to be able to do this next time.
Mhm.
Looking at AI, the safety part of it now. You see, the Prime Minister here in the UK, able
Mhm.
to establish the AI Institute, Safety Institute. How do
Mhm.
you see this plays out when it comes to the present GDPR regulatory and
Yeah.
the safety part of it? Even though you answered part of the question when somebody answered, but now comparing with regulation, is this something in terms of the risk? Is this something that when you have the entire product, will be approved, will be commercialized?
Mhm. So a lot of products are actually commercialized. Even in healthcare, there are parts which are commercialized and using AI based. It is, uh, but good thing we are living in the United Kingdom where the GDPR rule and everything is there, and it is quite important because uh, AI itself can be exploited. People can use it to steal a lot of data, and the protection of it is quite important. As I mentioned, for example, if we are using I will give an example of our own system. We are using RF based system using AI to monitor a patient, for example, and we are not making it quite secure, and any cyber based thief or theft can come and at the same time monitor that same patient without us being knowing about it. So AI itself can be very dangerous itself when you implement it and you don't have an automated secure system. So securing a system and the privacy is quite important. And the more we go into artificial intelligence, the more we are having people who are actually abusing artificial intelligence, using it to their own advantage, while it is a people monitoring, while it is taking money out of the credit cards, taking money out of the bank systems, or stealing somebody else's businesses, going into the marketing, doing false marketing, or acting as someone else. For example, deepfake is a huge example of it. For example, if I have a huge videos of you, next day I can come as a Timothy and I can be Timothy. I can actually mimic anything you say based on the deepfake. Whoever is not introduced with deepfake, they can go onto YouTube and see it. uh, and the beginning last year, actually, it could only mimic your face, but today I was watching a video and it can actually mimic your whole body now. So you can be moving around your room and it will do
Mhm.
exactly what you are doing by exactly your face expression, everything, and how your lips are moving, how your eyes are moving, and it's very hard to differentiate between the real one and the fake deep one. So regulating AI is very much important. And as I said, a lot of I mean, anybody can make Rishi Sunak video now and just put it on online, and nobody would actually know it
Exactly.
is Rishi Sunak. Yeah. So it is very important to put the cyber system and the privacy concerns and actually making regulatory this system with a lot of protection at its. Yeah.
Thank you, thank you, thank you. There are questions to talk about, but the time will not permit us. Is just exactly six now. You've mentioned man in the middle attack, even within the devices. Man in the
Mhm.
middle attack. You talk about confidentiality of the data, integrity of the data, and the availability. You talk about interference and the rest of it. A lot of things to discuss. Hope
Yeah.
to have more of your time
Yeah.
to begin to talk about this. I really appreciate you. Thank you, Kazim Jalili. Thank you, everyone. Hope you enjoyed it. It's a live session, and on LinkedIn, you can continue on Facebook and YouTube. You can continue to ask those questions,
Yeah.
and we'll be able to answer them. Thank you. Thank you. Have a blessed day. Bye
Thank you.
bye.
Bye bye.